Hello everyone. Yeah. Hello everyone. Very good evening. Kindly confirm if audio video is clear. Please confirm if audio video is clear so that we can proceed with the third lecture of relational algebra. So we have already discussed basic relational algebra operations in the first lecture of query language. In the second lecture, I have discussed one most important derived relational algebra operation, that is division operation. In today's session, I'm going to discuss one more type of derived relational algebra operation, that is join, right? So there are various types of join operation in the relational algebra. We will discuss all those different types of join operation in the today's session. So let's start, sir. So what are the topics? So basically, we broadly classify all the join operations in two categories: inner join and outer join. So, please, I know that most of you will think that this topic is easy, but as I said, natural join is one of the most important concept of database management system from the gate point of view. It will be required at three different places. One is to define, it will be required in SQL, it will be required in relational algebra, and apart from that, it will be required to solve the questions of normalization. When you decompose a relation into sub-relation such that its normal form improves, then we always try to ensure that the decomposition is a lossless join decomposition. And that's what we'll try to understand, that how exactly we ensure that the join is a lossless join with respect to decomposition of a given subrelation. Anyway, so let's see. There are two types of join operation: inner join and outer join. There is a simple differentiation between these two types of join operation. If only the tuples of the relations which satisfy the join condition are included in the result, then it will be called inner join operation. And apart from all the tuples which are satisfying the condition of join operation, if we also include the tuples either from left side relation or from right side relation or from both the relations, then it will be called outer join operation. So that's what we are going to discuss. First thing is, sir, why exactly do we need join operation? So when I was discussing the concept of basic relational algebra operation and I defined the cross product, then only I told you that when the query condition will evaluate tuple by tuple, taken one tuple at a time. So if at all you want to compare two different tuples of the same relation, or if you want to compare two tuples of two different relations, then you will have to join those tuples into a single tuple. So if there is no other condition, if you want to join all the tuples of first relation with all the tuples of second relation, then it will be called cross product or Cartesian product or cross join. So cross product is also a type of join operation which is known as cross join. Clear? So what happens? Join operation are used to join the relational tables. We join, that means we combine the tuples of one relation with the tuples of another relation such that they satisfy certain condition. Such that they satisfy certain condition. If there is no condition, that is, if you are not specifying any condition and you are simply joining two relations, then it will be called cross join or cross product. So please try to understand. If there is no condition to join the relation, if you are not specifying any condition, then it is called cross join. What do we call it? Cross join. Please. So please try to understand whether you say cross join or you say cross product or Cartesian product. They are all same. There's no difference between these three terms. The effect will be exactly same. What happens in cross join? So as we all know the concept of cross product, we know in cross join, every tuple of first relation will be combined with every tuple of second relation. Clear? So that's the basic definition of join operation, that we are trying to combine, or we are trying to join the tuples of first relation with the tuples of second relation based on certain condition. Now let's look at the classification. So broadly, we classify the join operation into two types: inner join and outer join. Within inner join, there are other classifications. First one is theta join. This theta join is also known as conditional join. So they may say theta join, they may say conditional join. Please try to understand. These are all the terminologies, and generally people get confused with these terminologies because they are all same, right? So, like we say equi join and theta join. So, what's the difference between equi join and theta join? A student will get confused, right? But the problem is equi join is also a type of theta join. Equi join is also a type of theta join, where the condition is going to be equality condition. Clear? In natural join also the condition will be equality condition, but in natural join the equality condition will be applied on all common attributes. There is no exception. The equality condition will be applied on all common attributes if it is a natural join. So we'll define each and every one of this inner join operation. Finally, the most important concept, that is natural join. So we'll try to understand that how exactly natural join is derived using basic relational algebra operation. Then we will specify outer join. So outer join will have the tuples from the natural join, and apart from that the tuples either from the left side relation or right side relation or both the relations, such that they are not satisfying any join condition. Okay, so we'll see what does it mean. So this three we'll discuss further. So let's go one by one. What is theta join? So sorry, this slide is repeated. 9. Inner join. So what's the definition of inner join? I just told you, but I did not show you the slide. So what is inner join? So in inner join, in the result, only the tuples which are satisfying the join condition or the join criteria will be present. Clear? So in inner join includes only those tuples. Inner join will include only those tuples that satisfy the matching criteria or join condition. Matching criteria or join condition. Same thing. Matching criteria or join condition. Okay, sir. Now, the very first type of inner join is theta join. So, what is this? So, it is the most general case of join operation. So, in theta join, it is also known as conditional join. Theta join is also known as conditional join, and the condition to join the tuples can be any condition. There is no restriction that what should be the condition to join two tuples of two different relations. So, theta join can use any condition. Any condition. It can use less than, it can use greater than, it can use less than equals to, it can use greater than equals to, it can use equals to, it can use not equals to. So it can use any condition to join the tuples in the selection criteria. So let's take an example. Let's assume that this is your relation student, this is your relation employee, right? So generally, we'll define the theta join using, let's assume if this is your relation R and this is your relation S, then we specify this theta, this can be any condition. Any condition, as we said, it can be any condition. So let's assume if I ask you to join the relation student. So as I said, condition can be anything. That is, we can apply any type of condition on any set of attributes. Any type of condition on any set of attributes. So if I try to join a student table with enroll table, so this is join. if we are trying to join the student table with enroll table based on some condition. Let's assume if I specify the condition as that student dot SID must be greater than or equals to employee.eid. Now you may be asking that, sir, why are you trying to join two tuples in which one attribute is SID, another is attribute is EID. So I'm just trying to explain that you can perform the join operation on any set of attributes, whether it is meaningful or not, it is up to you. That if you are joining two things, so can you make any sense out of that join operation? It's completely dependent on your understanding of the relational table. But if you join these two tables, a student has nothing to do with the employee. The table student has nothing to do with employee, but you can join the student table with employee table satisfying any type of criteria. Let's say that SID has to be greater than or equals to EID of the employee table. So if I do so, what will be present in the output? What will be present in the output? So just like cross product, so the very first thing that will be performed when you perform the join operation is that first you will perform the cross product. So you will have a student. So that's your result. So you will have all the attributes. You will have SID, attribute SID of student table. You will have attribute SID of student table. You will have attribute S name of student relation. You will have attribute EID of the employee table. Dot EID. Then you have employee department ID of that employee. Dot department ID. So what will happen? Sir, in the cross product, all these three tuples will be combined with all these three tuples of employee table. And finally, we'll check whether if these two are combined, if these two tuples are combined, then let's check with respect to this merged tuple, SID in the student table is greater than or equals to EID in the employee table or not. Yes, sir. Here SID is 1 and here also it is 1. So it is because of this equality condition. Because of this equality condition, one RAM will be combined. One RAM will be combined with 1 5, where 5 is the department ID. Similarly, in this specific case, 1 is not greater than or equals to 3. Therefore, 1 RAM 3 2 will not be present in the resulting table. 1 RAM 5 3 will also not be present in the resulting table because 1 is not greater than or equals to 5. In this case, 1 is not greater than or equals to 3, but 1 is greater than or equals to 1. Clear? So, this will be the only tuple available with respect to 1 RAM of student table. Now let's check. When 2 Tom is combined with 1 5 in the cross product, is the 2 greater than or equals to 1? Yes, sir. 2 is greater than or equals to 1. Therefore, 2 Tom will be combined with 1 5. Similarly, 2 is not greater than equals to 3. Therefore, 2 Tom will not be combined with 3 2. 2 is not greater than equals to 5. Therefore, 2 Tom will not be combined with 5 3. Now let's look at this. Sir, 3 Jerry will be combined with 1 5 and 3 is greater than equals to 1. Therefore, 3 Jerry will be combined with 1 5. And apart from that, 3 is greater than equals to 3. Therefore, 3 Jerry will be combined with 3 2 as well. 3 Jerry will be combined with 3 2 as well. So I just wanted to show you that what will be the output after the join of student table and enroll table based on this condition. Clear? So that's one criteria. Now you may say that, sir, is it necessary that the condition will always be on the different set of attributes? No, sir, condition can be anything. So we can apply any condition. So that's the idea of theta join. We can use any condition to join the tuples. Okay, so this is theta join, which can use any condition. Next one is equi join. Next one is equi join. So equi join is a special case of theta join. So it's nothing new. It is just a special case of theta join where the condition for join operation is guaranteed to be equality condition. So if you say, if I say that equi join is a subset of theta join, there will be nothing wrong in that, right? So I can actually say that this is equi-join. An equi-join is a special type of theta join. Therefore, all the equi-joins are theta join as well. All the equi-join connection are theta join as well. Now, what will happen, sir? In equi-join, the condition is always equality condition. But is it necessary that this equality condition will be on common attribute? No, sir. The condition has to be equality condition. Condition has to be equality condition, may or may not be on the common attributes. May or may not be on the common attributes. Okay, sir. Let's say we again have the same relation, but this time if you are using equality condition, let's say if I say join student table with employee table, did I use the same thing? Oh, it was supposed to be employee. This is the employee table that I'm joining, right? So student joined with employee table. Generally, we just join student with enroll because the student will enroll for some courses. So it was there in my mind, but it's okay. We can use any type of join operation. So let's say assume if a student table is joined with the employee table based on the condition that SID in the student table should be same as EID in the employee table. So I can do so. Yeah. So the student.SID must be equals to employee.EID. Clear? Now, sir, because of equality, it is equi-join. Because of equality condition, it will be called equi-join. And what will be the output of this equi-join operation? So that's one thing. That's we'll have a student dot SID. We'll have a student dot S name. We'll have employee dot EID, and we'll have employee dot department ID. Now the only thing that you must understand is that the tuples which will be present in the resulting relation will be the tuples satisfying this criteria. So one combined with this one. So yes, SID is equals to EID. Therefore, one RAM will be combined with 1 5. This one is not equals to 3. This one is not equals to 5. Done, sir. Let's look at the second one. So this 2 is neither equals to 1 nor equals to 3 nor equals to 5. Therefore, this will not be present in the relation. Similarly, this 3 is equals to this 3. So 3 j will be combined with 3 too. It's a simple relation, but please, you may be thinking that sir, it is an easy task. But until you understand all the operations, you will not be able to solve the question of relational algebra. Therefore, it is the very prime requirement to understand all the operations in their entirety, so that you will be able to solve each and every question of relational algebra, and that's the objective of having this series. Okay, so that's one concept. That's a we may have the equality condition on the different attribute, or we may also have the equality condition on the common attribute. But does it make the join operation a natural join? No, sir. So let's look at this. Sir, if I have these two relation, one is a student, another is enroll. If I perform the operation student joined with enroll table such that the attribute SID, so there is only one common attribute, that is SID. If this attribute SID is equals to the attribute SID in the enroll table, so again it is equi-join because of equality condition. But that's what we do. But that's what we'll do in the natural join as well. But does it make a natural join? No, sir, because there are some special things associated with the natural join that we are going to understand in a while. So what will happen? Sir, a student joined with enroll table will have same information, don't change too much. So this is student.sid. Student.sname, enroll.sid, and enroll.cid, that is the course for which the student has enrolled for. What will happen? The SIDs must be equal. The SIDs must be equal. So this one will be combined with this one will be combined with this one. So one RAM will be combined with one C11, one RAM will be combined with one C05, one RAM will be combined with one C05. Now, this 1 is not equals to 3, therefore this 2 will not be combined. 2 is not equals to any one of this 3, therefore 2 also will not be combined. And 3J is equivalent to 303. 3J will be combined with 3C03 because these values are equal. Come on, this is the condition to perform the join operation. Now, if you performing the equi-join operation, attribute SID, though it is a common attribute, but it will be present with respect to both the relations. Clear? So that's the difference. That's what make the equi-join different from the natural join. So what's the idea? Attribute SID from both the relation will be present in the output. So this attribute SID with respect to student table will be present, as well as attribute SID with respect to enroll table will be present in the output. Clear? So that's the difference, that you may perform the equi-join on the different types of attributes or different names of attribute. You may perform the equality condition on this common attribute as well. But the only difference is that if you are performing it, even if you are performing it on the common attribute, then also those common attribute will be present in the output relation from both the input relations. Okay, then what's the difference with respect to natural join? So let us define the natural join, which is most important operation from the database management system point of view, right? So though whether it is related to relational algebra or related to SQL or related to decomposition, normalization, right? So what is this? A natural join is performed based on what? Sir, come on. Natural join is performed based on equality condition on all common attributes between the relation. Whatever the common attributes are between the relation, on all those common attributes, equality condition will be performed. But if you are using the natural join operation, you don't have to express the condition explicitly. The moment you say natural join, it will eventually be the equality condition on the equality condition on all common attributes. So we don't need to express the condition explicitly. No need to write the condition. The natural join includes the concept that there will be equality condition and that equality condition will be applied on all common attributes. Clear? So additionally, what happened with the equijoin? We were checking for the equality condition on the common attributes SID from the relation student and enroll. So in the output relation, SIDs from both the relations were present. But in natural join, what will happen? Additionally, a natural join removes the duplicate columns, will remove the duplicate columns involved in the comparison. So, if SID is there with respect to a student table as well as SID is there with respect to enroll table, then there will be only one SID in the output with respect to natural join. So, only one of each compared column remains. So if you have compared 6 different attributes, like 2 attributes from each relation, so if you have made 3 different comparisons, then rather than 6 different attributes in the output, there will be only 3 attributes in the output relation. So anyway, that's perfectly fine. Let me elaborate the natural join in more detail, because it will be more useful when we will learn the concept of natural join. When we'll learn the concept of decomposition. So what is natural join? So natural join is a derived relational algebra operation this is important, please. Is a derived relational algebra operation which is derived using three basic relational algebra operations. Three. Every join operation is derived using them only, but there's a different way. Three basic relational algebra operations, that is cross product is one basic relational algebra operation. Second, selection. Third, projection. Right? This will be cross product, selection, projection. These three things will be available in the natural join. So let's look at the example. Let R and S are two relations. Let's say the attributes are A, B, C. Let's say the attributes are A, B, C, and S is another relation with attributes B, C, D. So what are the common attributes? So the common attributes between R and S are B and C. The common attributes between R and S are B and C. So what will happen? So let R and S are two relations. Then how do we define the natural join of R and S. Please try to understand. With respect to natural join, no condition is specified. With respect to natural join, no condition needs to be specified. Come on. So, I'll explain the same concept in two different manners. So, if you want to perform the natural join of R and S, then what will be the relational algebra expression using the basic relational algebra operation to derive this natural join? So, what will happen? So, the very first thing that will be done is obtain R cross S. So, the very first thing that will be done to derive natural join will be R cross S. So, first of all, we'll perform the cross product of R and S. So, in any join, the very first thing, any join, whether it is theta join, equi join, natural join, whatever you talk about, the very first operation that will be performed will be the cross product. Then you will apply the condition based on the condition available with the join operation. So, if it is a theta join, condition can be anything. If it is a theta join, condition can be anything. But if it is a equi join, condition will be equality condition. But what set of attributes that equality condition needs to be applied will be defined explicitly with the join operation. But in the natural join operation, you will not specify any condition. Condition is guaranteed to be equality condition on all common attributes. So, the second thing that you need to do is select the tuples from R cross S based on equality condition on all common attributes. So, it may be the case that there are more than one common attribute. It may also be the case that there are no common attribute. So, please try to understand. The second thing is, you'll have to select the tuples from this R cross S. So, on this R cross S, you will have to apply the selection condition. What will be the selection condition? That whatever the common attributes among R and S are, on those attributes you need to apply the equality condition. So, in the relation R, there is an attribute B. In the relation S, there is an attribute B. So, this two must be equal. And, sir, this equality condition must be on all common attributes. Therefore, R dot B must be equals to S dot B. And one more common attribute between R and S is C. Therefore, R dot C must be equals to S dot C. So, you will select those tuples. In which all common attributes are equal. Finally, the last thing that you will do is that project distinct attributes. Come on. You know that B will appear in relation R as well as in relation S. C will appear in R as well as in relation S. Therefore, you will not have the attribute B from both the relations R as well as S. You will not have the attribute C from both the relations. You will take it only from one relation. And the logic is quite simple. That both the values are equal. So, why repeat the same value again and again? You can actually see that when we are looking at these values, this is 113, this column is also 113. Why have two duplicate columns? When you know that these are the values of SIDs only based on which we have joined two relations? Okay. Finally, project the distinct attributes or project the tuples from output of step 2 with respect to distinct attributes of R and S. So, sir, in R and S, there are 4 distinct attributes. One is A, another is B, another is C, and another is D. So, you will only project these 4 attributes A, B, C, E. So, in the output, there will be only 4 attributes. In the output, there will be only 4 attributes. Though there are 6 attributes if you add the attributes of R and attributes of S, but 2 of them are common. Therefore, in the output, there will be only 4 attributes. This is how the natural join will be derived. So, whatever is done by this set of basic relational algebra operation is actually the output of natural join. Is actually the output of natural join. So, let's look at the example. If I want to perform the natural join of these 2 relations, then you don't need to specify the condition. If you simply say R natural join S, if you simply say R natural join S, then by default, the condition will be equality condition on all common attributes of R and S. So, yeah, here the relations are student, natural join with enroll. So, we know in the resulting relation, there will be only 3 attributes. One is SID because it is common for both. One will be S name, another will be CID. So, in the resulting relation, there will be one SID, there will be one S name, and there will be one CID. And obviously, the condition will be equality condition. So, this one will be combined with this one. So, it will become 1. SID is 1. With respect to that, the value of S name is Ram. The value of CID is C11. So, you can first perform the cross product, then you can select the tuples, but you can simply look for the common values of attributes if you want. Similarly, this one will be combined with this one also because again SIDs are equal. So, common attribute is SID and equality is there. So, one RAM will be combined with course C05 as well. Okay, so one RAM will not be combined with SID3. This 2 will not be combined with any of the SID. But again, 3 will be combined with this 3. So, 3 Jerry will be combined with course number 03. So, I hope you have, now you understand, sir, these are the same operations. You can actually see. Same relation, equality condition on the common attribute, same relations, equality condition. By default, the condition is equality condition on common attribute, but the idea is in natural join, you don't have to express the condition explicitly. That's the one difference. You don't have to express the condition explicitly. In natural join, the equality condition will be applied on all common attributes. In equi join, it may be on some common attributes, may not be on other common attributes. Clear? In equi join, the common attributes from all the respective relations will be present, whereas in natural join, only one of the compared attribute will be present in the output from another relation. The compared attribute will not be present because the column values are going to be exactly same. Clear? Clear. So let's move to the next example and then we'll talk about 2 important properties of natural join. Let's look at this. So what will happen if you perform the natural join of these 2 relations? If you perform the natural join of these 2 relations, student natural join with employee. Okay, let me first give you an explanation, then we'll talk about that. Come on. We know, I already, first case, we know that if R is a relation with attributes A, B, C, and S is a relation with attributes B, C, D, then we know that R natural join S will be what? Right? But second case is, if R is a relation with attribute A, B, C, and S is a relation with attributes D, E, F. So, how do you define the natural join of R and S? How do you define the natural join of R and S? If you try to define the natural join of R and S, the very first thing that you will do is you will perform the cross product of R and S. Yes, sir, that's what we do, right? Then the next thing has to be selection condition on all common attributes. There must be selection condition on all common attributes. But the problem is there are no common attributes in R and S. There are no common attributes in R and S. Therefore, there will be no selection condition. No common attribute. Between R and S. Therefore, no selection condition. If no selection condition is applied, then ultimately all the tuples of R cross S will be present in the output. And finally, you will project distinct attributes A, B, C, D, E, F. Please try to understand from R cross S without selecting anything. If you project all the attributes, it is actually nothing. It is actually nothing but R cross S only. It is nothing but R cross S only. What does it mean? That is, if there are no common attributes between the relation, then the result of natural join will be same as the result of cross product. Clear? If there are no common attributes, between the relation, then natural join will behave as cross product. No difference. No difference. So the result for this will be nothing but student cross employee. The result will be, so here we have attribute SID as name. Here we have attribute EID, DID. The names of the attributes must be same. Names of the attributes must be same. You may say, sir, there are common values. It has nothing to do with the value. The names of the attributes must be same in the corresponding relations. Clear? Because no common attribute. Okay. What I'm going to explain here may not be important from the relational algebra point of view, but that concept will be important from the normalization point of view. Therefore, you can have them as notes that first, sir, natural join is commutative, tuple wise. Come on. Sir, if I perform R1 natural join with R2, if I perform natural join of R1 and R2, then this will be same as the natural join of R2 and R1. The only difference is the order in which the attributes will appear with respect to R1 natural join R2, and the order in which the attributes will appear with respect to R2 natural join R1 may be different, but the result will be exactly same. That is, the tuples which are present in the output will be same. Tuples in the output will be exactly same. I'm not talking about the order in which the attribute will appear, because obviously in this case first the attribute of R1 will be there, then the attributes of R2 will be there. In this case first the attributes of R2 will be there, then the attributes of R1 will be there. It's a different information, but we are saying the order of attribute may be different, but the tuples in the output will be exactly same with respect to corresponding attribute. Okay. Second property is natural join is associative. You don't need to go into the detail, but just remember natural join is associative. What does it mean? If you have three relations R1, R2, R3. So if you first perform the natural join of R1 and R2, then you perform the natural join of the result with R3, or if you first perform the natural join of R2 and R3, then you perform the natural join of the output with R1, then this two will be equal. This two will be equal. Again, final result will be same. At intermediate level, this thing may create some problem, or this thing may create some problem, but the final result will be exactly same no matter in what order you perform the join operation. Now, let me also explain one more important fact with respect to lossless join decomposition. What's that? No. If relation R, if relation R is decomposed into subrelations. So there is a relation R. So many things in this relation. Okay. If you decompose this relation, let's say assume that you have created three subrelations R1, R2, R3, whatever. Some of the attributes are present in this, some of the attributes are present in this, some of the attributes are present in this, right? So if you do so, that if you decompose the relation R into subrelations, R1, R2, R3 up to, let's assume any number of Rn, then in general, what will be true? In general, if you perform the natural join of all these subrelations, in general, if you perform the natural join of all these subrelations R1, R2, R3 up to Rn, then the result will be superset of all the tuples present in the relation R. So it is guaranteed that all the tuples of relation R will be present after this natural join, but it may be the case that there are some extra tuples in the natural join of this subrelation. Those extra tuples are known as spurious tuples. Those extra tuples are known as spurious tuples. If those spurious tuples are present, then your decomposition is supposed to be lossy. Sir, you may say, sir, at least we are getting all the information that is available in R and we are getting something extra. Then why exactly we are calling it lossy? Because all the information that was present in relation R is definitely available after the natural join of these relations. But the idea is, so this is the database. A piece of information will be correct information in its entirety. If you remove anything from it or if you add anything extra which is not actually present, then it will become incorrect information. Then it will become incorrect information. So you have certain information that S1 has enrolled for C1, S1 has enrolled for C2, S2 has enrolled for C3. In the output, if you know, in the output, if it is available that S2 has enrolled for S5 also, S2 has enrolled for C5 also, but S2 never enrolled for C5. But if this information is present after the natural join, then it's a lossy information because you have an incorrect set of database. You have an incorrect set of database. So that's what makes it lossy. Otherwise, all the tuples of relation R will be present. So it will not remain consistent. Clear? So please try to understand. There are two things. First is if the natural join is exactly equals to R. I hope you may be thinking that, sir, is it required at the time of relational algebra? No, sir, it is not required from the relational algebra point of view. So, if the natural join is equals to R, then decomposition, then about decomposition is lossless joint decomposition. Second, if it is proper superset, that means if you have any extra tuple, what does it mean? If R1 natural join with R2 natural join with R3 natural join with etc. up to Rn. If it is a proper superset, that means we have at least one extra tuple. We have all the tuples of R, but we have at least one extra tuple. Then decomposition is lossy joint decomposition. Lossy. That means even if you join, you will not be able to get the exact same information. Lossy joint decomposition. Third one, you can say, sir, is it ever possible that the natural join of all this subrelation is a proper subset of R? Come on, if it is happening that you must have committed some mistake, it is not possible. It will never happen that if you join the subrelations and you get the proper subset of R. That's not going to happen. Clear? Anyway, so we have understood everything related to inner join. Now let's move to the concept of outer join. So it is damn easy. What's the idea? That, sir, in the inner join we will only have the tuples which are satisfying the join condition. In the inner join, if you look at the output, then we will only have the tuples in which join condition is satisfied. But with respect to outer join, along with the tuples, we also include the tuples. Along with the tuples that satisfy the matching condition or join condition, we also include the tuples that do not match the criteria either from left or from right or from both the side relation. If you include the tuples from left side relation, it will be called left outer join. If you add the tuples from the right side relation, it will be called right outer join. If you include the tuples from both left as well as right side of relation, it will be called full outer join. Clear? Chale. Come on. So what is left outer join, sir? How do we denote this? This is the notation. This is the notation for left outer join. So what will be left outer join? Sir, what will it be? So it will be, first of all, it will contain all the tuples of R natural join S. So it will be nothing but tuples of R natural join S along with, come on, tuples of R natural join S along with, so left, we are talking about left outer join. That is, therefore, you will take the left side relation along with tuples from left side relation join condition. Come on, sir. Let us take an example. So, let's assume this is your relation R with attribute ABC, this is your relation S with attribute BCD. If you perform the left outer join of R and S, then first of all, you will have the tuples of natural join. So let me first write the output of R natural join S. So the output of R natural join S will be nothing. Output of R natural join S will have the distinct attributes A, B, C, D. Matching criteria, sir. R dot B should be equals to S dot B and R dot C should be equals to S dot C. So this 2, 3 will match with 2, 3, but this 7, 9 will not match with this 7, 7. Therefore, what will you get in the R natural join S? Sir, A, B, C will be 1, 2, 3. A, B, C will be 1, 2, 3. And the value of D with respect to BC value 2, 3 are 6. So this is your natural join. This is your natural join. If you talk about left outer join, then again you will have the same set of attributes. You will have the same set of attributes as a natural join. So it will include the tuples from R natural join S, that is 1, 2, 3, 6 will be present. So this is from R natural join S, right? But apart from that, you will also have the tuple from the left hand side relation that failed the join condition. So this tuple 4, 7, 9 was never a part of join operation. This 7, 9 did not match with any of the tuple of relation S. Therefore, this tuple 4, 7, 9. This tuple 4, 7, 9. So this is the extra tuple from R will be present left hand side. Left hand side. Extra tuple from R 479 will be present. But now you'll ask, sir, that what will happen with the D value? Sir, there is no tuple, no attribute D with respect to relation R, and we are taking the tuples from relation R. Therefore, this value is guaranteed to be null. This value is guaranteed to be null. So that's your R left outer join S. Another is the right outer join S. So, sir, what is right outer join? So again, it's simple. What will be right outer join S? Sir, right outer join S will be nothing but the tuples of R natural join S along with the tuples from right hand side relation that failed the join condition. So, tuples of R natural join S along with the tuples from right hand side relation that failed join condition. So what will happen with respect to same relation? If I define R right outer join S, then you will have the tuples of R natural join S, that is A, B, C, D. First of all, you will get the tuples 1, 2, 3, 6. You will get the tuples 1, 2, 3, 6. Perfectly fine. but there are some tuples in the right hand side relation which were not part of any join operation. So 2, 3 combined with this 2, 3 of relation R, but this 7, 7 did not combine with any relation. So the value of B will be 7, value of C will be 7, and value of D will be 2. But there is no attribute A in relation S. Therefore, at place of A, you will have to put null value in the right outer join. Now it should be clear that what will be full outer join. So what will be full outer join? The full outer join will be denoted using this, that our right side as well as left side. So this will be what? So it will be tuples of R natural join S, tuples of R natural join S along with tuples from both left and right side relation. Left hand side and right hand side relations that failed join condition. Clear? So this time if I define the full outer join, so R full outer join S will have A, B, C, D. It will have the tuple with respect to natural joint, that is 1, 2, 3, 6. Will have the tuple with respect to natural joint 1, 2, 3, 6. Apart from that, what will happen? So this 4, 7, 9 was not part of join operation. Therefore, 4, 7, 9. 4, 7, 9 will be from the left hand side relation, and with respect to 4, 7, 9, the value of D will be null. And with respect to right side relation, we will have 7, 7, 2. We will have 7, 7, 2, and with respect to that, the value of A will be null. With respect to that, the value of A will be null. Clear? So I hope this thing is also clear. So these are all the easy concepts, but if at all a question is asked, then you must be able to explain it, or you must know the right answer for that particular concept. So that was the only objective, that you don't have any doubt related to inner join, the difference between inner join and outer join. You must be able to differentiate that what exactly inner join is, what exactly outer join is. In inner join, only the tuples that are satisfying the matching criteria will be present in the output. In the outer join, along with the tuples that are satisfying the matching criteria, also the tuples that have failed the matching criteria will also be present, either from the left hand side relation or from the right hand side relation or from both the relation if it is full outer join. Theta join can use any condition on any set of attribute. Equi join can use equality condition on any set of attribute. Natural join is guaranteed to use equality condition on all common attributes. Left outer join, all the tuples of natural join along with the tuples from the left hand side relation that failed the join condition. Right outer join, all the tuples of natural join along with the tuples from right hand side relation that failed the join condition. Full outer join, all the tuples of natural join along with the tuples from left hand side relation as well as from right hand side relation that failed the join condition. So that concludes the topic of join, different types of join in relational algebra. Will generally use natural join or outer join in the relational algebra. The other types of join, equi join and all of them will be used with the SQL. They have the notations for them, so they will be used along with the SQL. But yeah, these are the different types of join operation. Perform the cross product, apply the selection condition, whatever based on which you want to select the tuples, and finally project the attributes. Either you will project all the attributes from both the relations if it is a normal join, but if it is a natural join, you will project distinct attributes only. So it's the only difference, and that's what. So basically, we have concluded the concept of basic relational algebra operation as well as derived relational algebra operation. Tomorrow we'll see some good quality questions that have been asked in the GATE exam from this topic of relational algebra, and then from next class onwards we will start with the structured query language. So that will be all. Thank you very much. See you tomorrow at the same time. Till then, keep learning. Good night.